Hi, thank you for coming to see my presentation. I'm Chaeyong, a PhD student at Interaction Laboratory Post-Tech, South Korea. I'm going to talk about our paper, Augmenting Perceptual Length of Handheld Controllers, Effects of Object Handle Properties. This work was conducted under the guidance of my advisor, Professor Seungmoon Choi. In virtual reality, users typically interacted with the virtual object using handheld controllers. However, typical handheld controllers have fixed shape and size, so they cannot represent the perceptually similar shape of various virtual objects. Thus, the user experiences of visual and haptic data are not consistent. To address these issues, several researchers have proposed shape-changing controllers as a solution to provide visually and haptically congruent sensory experience in virtual reality. To design the best matched visuo-haptic experiences, we needed to consider two types of physical properties of a handheld object: the moment of mass distributions and the handle properties. There is an extensive research on object shape perception, such as length, width, heaviness, volume, and orientation, related to the moments of mass distribution based on the concept of dynamic touch. But we know little about the effects of handle properties except for the handle diameter on shape perception. Our research group investigated the effects of the aforementioned two properties on shape perception and reported on the related research. We want to take a step forward by focusing on handle properties, specifically material properties, in shape perception, which has been relatively unexplored. In this paper, we explore the effects of the material properties of the handheld object on shape perception. We hypothesized that the different physical properties of a handle can alter the perceived length of the object even though the moments of mass distribution are the same. To find out the effects of material properties on length perception, we conducted 3 perceptual experiments. In the experiments, we focused on the effects of the softness, thermal conductivity, and the texture of the handle on the perceived length. This figure shows the structure of the physical object we used. The object consisted of an aluminum rod, a handle, and 2 brass discs. This shape of object has an advantage in changing the material properties of the handle and moments of inertia easily by maintaining mass. Before introducing the contents of the experiment, please note that the moment of inertia, called MOI, is an important factor in length perception regardless of the actual length. Thus, in this research, we used the several ranges of the MOI to see the effects of the handle properties in the large spectrum of perceived length. During all experiments, the experiment was conducted using magnitude estimation. Participants willed 2 objects, a reference object and a comparison object, and then responded with the perceived length of the comparison object compared to the perceived length of the reference object. Let me explain the contents of the experiment in order. The first experiment aimed to measure how the softness of an object handle changes its perceived length. There are 2 independent variables, MOI and softness. MOI has 3 levels from the very short to long, and the softness also has 3 levels. Those MOI ranges can cover various lengths of the physical objects, from a commercial VR controller to a large tennis racket. This is a rigid handle, a soft handle, and very soft handle with a silicone housing. These are the results of the experiment 1 with several box plots depending on MOI and handle properties. the result shows that the perceived length increases as MOI increases, which is consistent with several previous studies. We also found an interesting discovery. The softness of handle increases the perceived length even when MOI is constant. Thus, our experiment verified that a softer handle can increase the perceived length despite the same moments. We think this interesting discovery may be related to the delayed talk. When the user views an object, the softer object transmits the delayed talk because of the surface deformation. So this delayed talk may result in the perception of an extended manipulation period, contributing to a greater length perception. Then, we conducted another experiment to test the effects of the thermal conductivity of the handle on the perceived length. The independent variables were 3 MOI levels, the same as in experiment 1, and 2 levels of thermal conductivity. We made the low thermal conductivity handle using 3D printed plastic and the high thermal conductivity handle using an aluminum cylinder. Here are the results. Similar to the previous experiment, the larger MOI increases the perceived length of an object. Interestingly, the thermal conductivity of the handle also affects the length perception. Contrary to the results of MOI, higher thermal conductivity decreases the perceived length. We think there are 2 reasons. Firstly, users generally infer that a high thermal conductivity object is a metallic object with high density, and the metal object may lead them to infer that the metal object should be shorter to maintain the same moments. Thus, high thermal conductivity metallic handles provide a perceived shortening of length. Secondly, because cold sensation increases the perceived hardness based on the results of the experiment 1, so the harder object induces a shortened perceived length. Finally, we conducted one more experiment to investigate the effects of the handle surface texture, in other words, bumpiness. We used the same 3 levels of MOI and 4 levels of texture with different bump width and height. None, medium bump, small width bump, and large height bump. This is the result plot and illustration of various types of texture. As we expected, the MOI of handheld object has a significant effect on its perceived length. Furthermore, the result shows that the effects of surface texture on length perception is also significant. An object perceived length increases when small width bumps are added to the handle, but decreases when a large height bump are added. We cannot be sure of the exact reason for the texture effects. However, we speculated that the skin deformation affects the weight perception depending on the irregular pressure distributions inside the palm and fingers. We will conduct detailed investigations for further research. Let's sum up the results of the 3 experiments. A high thermal conductivity handle can decrease the perceived length by up to 7% compared to the normal handle, while a soft handle or textured handle can increase it by up to 11% and 8% respectively. These are key findings of our study. First, MOI has a significant effect on length perception consistent with the previous studies. Second, a softer handle increases the perceived length. Third, a handle with higher thermal conductivity decreases the perceived length. Fourth, handle texture bumps also alter the length perception. This is the end of my talk. Thank you for listening.